Let me start.
Did you manage to put it on Binder?
No, I didn't attempt it. So I'm not pretty much interested in Binder or stuff.
Okay.
So so I'm not sure like what we can discuss from chapter 2, because the first part of
we
the
had
chapter
already
2,
covered most of it. Yes.
Yeah, so basically it was all about the data book. Data loaders and data loader, data blocks. So I think that was the primary part of this chapter 2. So let's review it a bit, a small review. Yeah, and then we can
Right.
well. So I have been trying on my own, not looking at the. I have been following, but like I have been typing each of down, so it's a bit.
That's what I do.
Yeah. So I have a different notebook totally for it, where I type. It's a bit different from how it is there in the book, Fast book.
Okay.
So. Okay, now let me, sorry.
Yeah, sure.
Not this one. Give me a second. Okay, so let's start with, I have a my own data set. I couldn't get the Microsoft Bing search image API to work, so I had uploaded a few images myself, so I'm working with that. If you really want to see, it has like a bunch of images that I downloaded. But I did do it in the same structure, like in the trees and in the blacks and grizzlies and the teddy.
What are you trying to classify here?
Okay, so we are going to chapter 2. Chapter 2 was all about bear classification, right? If you remember. Right. So they gave us so what Jeremy said was talked about was a bear image classification. And he basically, chapter 2 was all about introduction to the libraries that are present, the high level APIs that are present with the Fast.ai library. So here I have my own URLs kind of stuff of Black. I downloaded them. I uploaded these images myself. This image links, and then I got to work with it.
They're also bare images?
They are all bare images, yes.
Okay, all right.
So, yeah. So, I couldn't get to the Bing search image if I have multiple tries, so I just did it myself. Yeah.
I also shared a link with you. So we discussed this in the last meeting, if you remember. And you know...
I got that, but I already had created my own. So, that's a good one. Actually, it's a lot simpler than what I had done.
Okay.
But yeah. Okay, so this chapter introduces us to build a small project. So it talks about the computer vision and stuff.
I think we have covered most of this thing.
We did.
This chapter, though.
Yes, we did. I think we did. So we didn't talk about this drivetrain approach, though. This defined. I am not sure I completely understand this part. I know what it tries to do, but like I haven't been able to, figure out.
Right.
Yeah.
He doesn't really give us good examples around it. He does talk about it in another course, but he talks about levers that you can change and then putting them in the model and then using those levers to make the predictions so that you can probably influence user behavior based on that. But he doesn't really give any examples around.
Yeah, so that was like I couldn't. So I just like to we didn't. So I think last course we discussed only the code, which is I believe only a small part of the whole AI stuff. I think we should be discussing the concepts as well. And so this drivetrain was something that I got to understand, but like not completely. Someone asked me to explain what the hell it is, I will be like, like that kind of stuff. So I went to this link and stuff, but like I still have not much clarity on this. Do you have anything about this?
What I understood was, instead of using all the variables just to make the predictions better, what the objective of a modeling exercise should be, that you have variables that you can change. If it's a variable that you cannot change, then just making the prediction will let you know that this is going to happen, but you cannot really do anything about it, right? Let's say you are trying to predict telecom churn, all right, a customer who's going to stop using your network. So you have variables in there which are like, what is the plan that he has, what is, how much data he has, what is the price of the plan and stuff like that. So these are levers that you could probably change or customize it according to a particular user, right? And then you realize that because the plan is priced so and so amount, he's about to churn. If you are able to identify that, then this lever you can alter. You can send him a, probably a customized offer that we are reducing your price with the same package, and then you can prevent the churn. Instead of that, if you had a variable like customer age, customer gender, and all of those things, these are things that are static. You cannot really do anything about it, right? They will help you improve your prediction, but they do not tell you, if there is anything you can do to modify the customer's behavior.
Okay. So basically,
that's what I understood.
So building models, but like I still I had thought of few scenarios. I was like still classifying it into levers, and so levers is something we can control, and data is something we collect. But like, aren't they both interrelated? Like, so that was I was having a hard time to group certain actions into these two categories. Yeah, modeling is pretty easy, and objective is once you have defined. So I was a bit confused there, but yeah, I'll revisit. So this is something that I will revisit later.
Okay.
And so we had this few examples here. So basically, what we did was basically we downloaded the image set. We created different directories so this step is all about creating different directories and pasting and copying the images of each data set into one. And then we created different data blocks, right? Data block. So that was a pretty interesting concept, the data block, data loaders, and data loaders. So three big stuff that we had. And we also got around to the concepts of random resizing and data augmentation, transformation into batch size. Yeah, so that was a pretty good concept about the mini batches, so that GPUs can take advantage of it, right?
I am slightly confused about item transforms and batch transforms. He does say that batch transform happens on GPUs, item transforms happens one at a time, something. But
yeah, so that's what. So for example, from what I understand, basically you transform. So item transform is like squishing or padding or taking a part of an image or cropping an image, right? Those are the parts of item transformation. So basically, you take in how a particular image, how you deal with it, right? Yeah. That's the item. So it's like item, you are transforming the image. And batch transformers, I believe, is where the GPU comes into picture. So basically, what Jeremy was saying is, if you don't do batch transformers, it will take a while. Whereas if you have batch transformers, you can group together. You can create something called as mini batches. You can basically like 10 or 20 or 50 or I think it's basically 128 images depending upon your GPU. You can group together and the GPU will do its processing.
So for the entire batch, they're gonna increase the contrast or something, or for each batch, few images have a different augmentation, others have different augmentation.
So I think so basically, for example, here it says min scale is equal to 0.5, right? So so for example, let's say this is the there's in this remove the unique is equal to 22 different images. So we will say like there are 5-6 images, it crops to the top right kind of stuff. Then it takes the batch, whatever, like the item transformation decides how our source image gets transformed to that. And batch is basically for computing all the data, so learning stuff, right? Basically vectorizing and all those stuff that happens. That is for that things are done in parallel, and for that batch transformation is being used. So basically, batch transformation is all about tensors.
Right. Yeah, I get the part about item transform, because each image is a different size, and then you would have to resize them to the exact same size. So each item transform has to happen one item at a time. And with batch transform, what I was confused about was, are they doing the same transformation on entire batch? So since
yes. So I believe item transformation is where the transfer. So batch transforms, I don't believe that it is actually a transformation.
Increasing the contrast in brightness.
It's like a single batch. They will be doing a lot of stuff.
Yeah. Okay. All right.
Yeah, you're saying something?
No. Waiting for you to say.
Yeah, and then there is a fine tune. Basically, we use a CNN learner, CNN convolution neural network. I have to read up on it. And the ResNet 18, which is basically the image classifier algorithm, right? And then there's a fine tune for 4 epochs. And by the end of the 4th epoch, so from the first epoch where we had a 0.76 string loss, we went down to 0.37. So that was pretty good. And seriously, I tried it on my manual. I have a PC. I tried it. Took around 5 minutes for each of this to process. So previously, I had tried doing each of this in my own system, and it took a lot of time. And then I moved to gradient and with the Tesla GPU, NVIDIA GPUs, and it takes around quite fast, like none at all. So that was a huge difference. Previously, I used to work on a machine, but now I've moved in the gradient workspace. And then for this data, there was this classification, basically, which confusion matrix, which is what was the actual versus predicted. That was a pretty neat one. And here I was basically the UI to sort this out. Do you think that the prediction is fine? Do you think the prediction is not fine? So that was good. So I think that was all about the data. And after that, actually, I think we had finished here. And then the other part, the rest of the chapter was all about putting this into a production, making it deployable, binder and stuff. I did not do it. I don't right now I have no need of doing it, so I didn't do it.
So how would you otherwise do it if you had to do it? I mean, have you previously done productionization?
No. So I could. So basically, if I do want to predict and stuff, I can do it here itself. I don't have to put into a binder and stuff, right?
Mm-hmm.
We can use this.
Just in case, since you're a developer, I'm just generally asking, like, if you had to deploy a model.
Oh yeah. So basically, I'm a web developer, full stack kind of I do the UI part and the backend with Java and stuff like that. So we have a different production environment and stuff. We have our own servers, like Node.js servers, Apache servers for the Java backend and stuff like that. That's where we deploy. And even if it goes to production, I think I'll be using that one definitely rather than Binder. I believe Binder will help you, but it has its limitations. Right? I mean,
it's a very basic deployment just to showcase that it
at
works.
the end of the anything that's just tells you to do this and do that and you're finished. At the end, it's too simple for any for any complexity. Not taking away the beauty of it, but like it will be very it won't be very much configurable.
Right.
So if I do have to do that, I think I'll be doing via the Flask API. So Flask is something by which a Python the environment and everything. So you have UI and you can interact with the Flask API and stuff with the backend, which is a Python code. So I haven't gone down that route much, but I have just had a couple of sessions on that. So I know, I just have a brief idea about it.
Okay, so you'll export the model in some format, pickle or something, and then you would
Right, but like it will be on a server. I wouldn't export it. I would say I would have it, for example, like a server which will have this data, this basically predictor, and when the UI, it will call the server. So basically, another binder also would have done that. I believe that's what they're doing. Also, like there's a server which UI calls to get the job done, and that's what happens. It's basically a bit of different kind of server where we have much control on what kind of data we want to process and stuff. I wouldn't say pickle file would be my like exporting a pickle, because at the end of the day, pickle file, if you do any kind of export you do, it's a static module. Like you cannot improve upon, right? If you have to improve, then it's a total different. And like in production, you can't have two different environments. Like one is a learner, and then you will export. That would be not be scalable. So we would have a kind of a system that has both the ability to predict and, if needed, an ability to learn as well.
Yeah. Okay.
Yeah. So retrain and stuff. So something of that kind would be my preference. But I mean, at some point of time, I'll definitely do it. But right now, it is not on my list. Like it's way down on the list.
Okay. All right.
And towards the end of the chapter, there was some really good stuff that Jeremy talked about, which is the out of domain data and domain shift. So out of domain data is basically, for example, if it's a video feed of bears, or like if it's just parts of bears that you can't see the environment. So all of these parts like are pretty well lighted, these pictures, right? They have pretty well lighting. If there are dark images shown to it, which you might not have trained on, so that our model may not very well work on that, right? Because it has a different pattern. A video, for example, of moving bears, and so that's something called as out of domain data. And he said that could be an issue, and we have to think about how to deal with that. And he also talks about something about domain shift. For example, domain shift is basically when you the parameters of the original data change. May not be the pair, it may not be a best example, or maybe we would have trained on large bears, but small bears come into picture, right? And our image, they may not have that black hair, or they may not have those structures completely formed, right? Which would say that this is a bear. So that's it's a complete domain shift. Working with child bears, or like if they have a different structure. For example, in butterflies, we would have placed butterflies, but a butterfly coming out of a cocoon is still a butterfly, but our image won't be able to predict it, right? So that's something called as a domain shift. And those are pretty two concepts, very good concepts. I believe domain shift is all about keeping your model still active, training it with new data once in a while so that it gets the whole picture. So yeah.
Right.
I mean, it's not pretty easy as well, like, because if it learns new data, it means it will forget some part of the old data. So that is where it gets a bit complex. How do you keep all the features intact? So, yeah. And he also talks about the deployment process, which is that first it's a manual stuff. You have both the vision API, like we have both this image classifier and a person to check this, and then you slowly scale it up, where the end state is that the neural network takes hold as the whole stage. But like you should start it with like 50-50, or like there is somebody to check on that.
I didn't get the last
those
part.
are the. So sorry. Sorry, I was not sharing. So this part, so where he was talking about how to actually deploy stuff, how to avoid disaster, and how to deploy. So first, you should have a manual process where like the process that this particular classifier it runs,
right,
and
right.
there's a human who is there to check all this, like whether okay, it is behaving fine or not. What are the error points? What are the points that it fails? So that could be a checklist, and we could improve our model on that. And the limited scope deployment, where there's a careful supervision and there is a variance, much more wider variance in the time and geography, like when to deploy, where to deploy and stuff. And then we scale it up properly so that at the end state is that it is a completely autonomous system.
Right.
So those are the stuff that we talked about, that this chapter covers basically. So any point here to like, do we need to discuss anything, or shall we go like anything that you learned, or anything that you would like to share, something you learned till here?
We covered. I'm slightly curious about retraining part, because I haven't never really worked on that thing where when you have incremental data and your model adds that information to the existing model. So I think they're going to probably discuss it in future lessons. Other than that, I have questions around data loaders and data blocks, but I need to experiment with them a bit before I can probably ask you something about it or discuss it.
Okay. So let's go at questionnaire one by one.
Yeah, sure.
So let's do it alternative. I'll take the evens, you take the odds.
Okay.
Yeah.
All right. First one. Provide an example of where the classifier model might work poorly in production due to structural style differences in the training data. Isn't this similar to out of domain data or domain shift data, where the test data or the the data on which you are predicting is much different from the data that you trained on, like videos and everything that you just talked about?
Yeah. The second one is, where do text models currently have a major deficiency? I believe text models are like the CC part, the closed captions. I think that's the best example of text, speech to text, right? Natural language processing comes into picture there, where the computer hears something and creates the text automatically, right? The closed captions on the YouTube. Yeah, the YouTube videos that we see, it has closed captions. Like those are not written by somebody. YouTube generally creates it on the fly.
Right. Okay.
Yeah, I think that is a pretty good text model, text, speech to text. And the deficiency I would like to see is it's not scalable to all languages. Like if it's an English one, it's pretty good at understanding, and I would say around 80 to 85% accuracy in the CCs, closed captions that we see during YouTube videos these days.
Mm-hmm.
But if you can't use that particular model for every language. Like if you try to do in a Hindi one, right, or any other language, not particularly English, then the model fails. Like it does not understand half of the words that are spoken. So I think text models have a major deficiency there.
Okay.
Your thoughts?
I'm not sure about whether it's still a deficiency, because there are these models called BERT transformation models, which perform pretty well on almost all languages.
Okay.
Yeah, because the challenge with text models is that they are not transferable, unlike the ResNet 18 or some similar models, which can be transformed.
Like the same model.
Sorry?
Because it's language. You cannot apply the same model because the model is language dependent.
Come again?
Right? No, I'm saying you cannot apply the same model. Like so that model is suited for English. You cannot give a Hindi audio and expect it to work fine for that.
Yes, I don't think that can be done. I'm not sure. But there's something called transformations. Transformation models in NLP that can be used for transfer learning. Previously, that was not possible with NLP models. So for any new data set, I think they had to create a new model with a new data set or something. But with BERT, it is possible to transfer an already existing model on a language onto some other model, other data set of the same language. I'll probably read more about it before I comment something more. What are possible negative societal implications of text generation models? Specific to text generation models, in general, I think machine learning models, you have to think about the societal implication, like the examples that we discussed about them classifying blacks as criminals and stuff. Specifically to text generation, there have been examples.
Yeah. So
Yeah, go
I think
ahead.
specific for text, again, I would say like closed captions, right? I mean, that's the best example of text I can believe. Or maybe even like things have gone pretty good, but like if there are, I think there can be negative social implications if the data doesn't, the model doesn't do a good transformation, like, or uh, the context isn't taken into picture, then what the user is saying could be quite different from what the model churns out, right?
Mm-hmm. But would you still classify it as negative societal implication?
Yeah, I believe it could be, right? I mean, so if a closed caption comes out without the context, right, and somebody is making a joke, a bit of racially sensitive joke, but CC doesn't capture that, right? The context properly doesn't capture that. So I think that could have serious implications. To a proper, if the audience is not, depending on the audience, they might take it lightly, or it can have serious.
Yeah.
I think that's.
Yeah, makes sense.
Okay, the next one, in situation where a model might make mistakes and those mistakes could be harmful, what is a good alternative? I think the presence of a human being, or at least somebody who can clear it out. What do you say?
Those mistakes could be harmful. What is a good alternative to automating the process? Jeremy talks about having
Having a human check it might be having human.
So you should try to ensure that you have people from different backgrounds in the team to ensure that the training data has all kinds of diverse information before you actually make it. And yes, eventually a human has to probably check it to ensure that it doesn't happen. So I think I went out of context there. I was talking about ensuring the that sort of thing. Yeah, I cannot think of anything else apart from what you said. Sorry. What kind of tabular data is deep learning particularly good at? image data sets where you have pixel information.
Yeah.
Yeah. Anything else?
I think tabular data where you can convert it to numerics, like data can be represented as numeric data. I think that would be something that deep learning would be good at, right? What do you think?
Right.
If you can categorize and then categorize into numerical values, I think that those are the kind of data points which deep learning can be good at.
And also you need to have more rows than columns. Like,
yes.
I mean, in case of images, it doesn't really apply, but when you other kinds of data set where, then you probably have to have limited number of rows.
Right. That's a good point. You should have more rows than data points.
Right.
Okay. Do I take the next one? Yeah. What's the key downside of using a deep learning model of recommendation systems? I think the policing activity was a very good example where, there's a positive feedback loop that comes into picture. So if you recommend something and then activities happen upon that, that is a downside, right?
Right.
Yeah, I think that is a downside which has huge implications. Like all your decision making is based on the recommendation systems without putting something into perspective. That would be a huge downside.
Yes. There was another point that they mentioned. He says that, the kind of recommendations that Amazon gives, where you buy something and it suggests, other items that you might like, is like pushing stuff that you would anyways buy.
Right.
It's not really changing your behavior or making it any better. It might be making better because you do not have to search for it, but it's not altering it in any way. He talks about doing stuff or making a model that suggests things that you should be buying, but you might, not search for, or you might not be aware of, something like that. I'm slightly confused about that. I mean, do you really need to do something like that? Or, just limit yourself to suggesting what they might actually buy?
I think it can border on creepy sometimes if it gets too much personal. Like if you know exactly so if I have bought something and I have something else in mind which may be totally unrelated, but somehow the system figure out or be creeped out. Like, I mean, it may not be in a bad interest, but like I would be creeped out. Like, how the hell did it know that when I have searched nothing related to it, right? I think there should be a bit of relations. Like, I understand that the books part that he mentioned, like, yeah, like if he already has that, then he might not need it, and he would say that anybody would say that, well, I already have this recommendation system is crap. But I think recommendation system, how it works now, is based upon the similar tastes of people. So I think it's like these are two different ends of pipeline, and we have to have somewhere in between, so that it works good for people.
Yeah, but he talks about changing the behavior. He says that, what Amazon does is basically pushing what you would anyways buy or something like that. And the model is not changing the behavior. But do we really need to change the behavior of the consumer? Or does the model really
No,
need to
I mean, you could try to, but like too much of it will creep out somebody. And I think it's one of the cases like, Jeremy gave a very specific example. He bought books and then he knows that, but like somebody might stumble upon that book and they might not know that it's another book. In that case, it's a good recommendation system.
Right.
So it has its pros, it has areas it can improve, and there are some areas where it has down, but like I think at the end of it, it's a fine balance between the two that we have.
Right. Okay. Yeah, I get. What are the steps of the drivetrain approach? Right, we just discussed that.
Yeah.
So you figure out the objective, then you figure out the levers that you can modify. So know the objective, and then you collect the data related to those levers, and then you can try to identify how you can, probably change the behavior by altering the lever.
How do the steps of a drivetrain approach map to a recommendation system? What's a recommendation system? Basically, it recommends something. So that's our objective, is to recommend based upon what search anyone has done. The lever data points that we have on them, what are the recent searches, what are the searches, what are the searches, or what are the products that a person doing the same search, other people think about, that are the data points that we need to collect. What are the levers that we have? What are the levers that we control on a recommended system? What are the products that we can recommend? I think that is the lever. I'm a bit confused about it, but I think this is how it is. The objective is to do a good recommended system. The levers are basically the search that the person is doing, the input of that, and the products that we have. Those are the two levers that we can control. The data points that we can collect are basically similar search results. So basically, people having similar tastes, what do they do? Right? And the model is building a recommendation system. I think that would be my steps. What do you think?
Yeah, it's what the user purchased and what purchases of similar product or the same product, what other stuff did they purchase, and
right,
based on that matrix, probably you'd recommend the one that is, which are most closest to the current product. Create an image recognition model using data you curate and deploy it on the web. All right.
That's an exercise.
I'll do that and share it in the next chat, next meetup.
So,
sorry?
So what's a data loader? Okay, so data loader is basically, data loaders, not data loader. Data loaders are basically something, loaders is basically a class that can contain multiple data loader. That's what basically a data loaders is. A particular data loader, I believe, which contains some data which can be transformed and broken into different batches. I think that is the job of a data loader, loading the data to GPUs and getting the output, training the model on it. Not training the model on it. So I think getting the data to the, loading the data to the GPU for, that is the basic job of a data loader.
Yeah, distributing it across different GPUs, different cores, yes. Mapping it to the cores, or maybe. Right. Next question. What 4 things do we need to tell Fast.ai to create a data loader? We need to share the data blocks. We need to share the transformations that we want to do. We need to share the Y label and the target label. And what else?
The source.
Batch transformations.
The source, like Y label is this output. I think the source.
So the source is the data blocks, isn't it?
I think source is basically the cat. So data blocks. So data blocks was particularly when you create a data block, you created with category, right? Categories, image block and category block. And I think there was something called get image something, get items, right? Which basically loaded the in. I think that is one input that we have to give the data loader.
Okay.
Yeah.
Yeah. Yeah, I can see that here. What actually is get items functions takes a path. Okay, it takes the address path of the place where everything is, where the images are.
Yeah. So converting a data block to a data loader. So I think at the end of the day, data block is an input to data loaders, right? You create a data loader from a data block. So it creates blocks, it creates this items. The splitter, basically how do you split to the labeling and the transformation stuff.
Mm-hmm. Splitter, is it mandatory to provide the splitter? I think.
No, I think it's like it has an option. Like it will take it by crop, right?
Yeah.
There's something related to crop.
Right.
Yeah, it crops into the central part.
No,
middle of the picture.
That is item transform, I guess. Or is it?
Oh yeah. Right. Sorry. Yeah. I think So Jeremy mentioned that on the valid data. On the valid data validation data set, they do a cropping of the center of the image, right?
Yes.
So that was a good point. Like that was a good question from Rachel.
Right.
Okay. What does the splitter parameter do? It splits the data into validation set and training set. I'm not sure whether it splits into test set or not. I'm sure that it has a validation and a train set for sure.
Yeah. Okay. Even I'm not sure about that. How do we ensure a random split always gives the same validation set? By setting the random seed.
Yeah.
In the splitter.
Mm-hmm.
Right. Okay.
I think that's right. Where's my data? Okay, sorry. How do we ensure and what are the letters often used to signify the independent and dependent variables? I think dependent variable is your output, so which is the get y label kind of stuff. Get y. So the output is the dependent and the inputs are the independent variables. So get items is the independent variable and get y is the dependent variable.
Right.
Or if it's variable naming, I think these are functions. Variable wise, it would be x and y. X is your input independent variable and y is your output dependent variable.
What's the difference between the crop, pad, and squish resize approaches? When might you choose one over the other? Cropping, picks a part of the image and then resizes it to the relevant size. Padding basically adds a particular padding to the size that it's smaller on, so the entire image is retained, but there is a lot of useless information that is added to the image and resizes it to the same size. Squish resize basically compresses it or stretches it on both of the dimensions to put them in the size that we want it to in a square shape. When might you choose one over the other? This I'm not so sure about.
Yeah, you still have to see. I think padding is a good solution, but I think I think if I didn't know about the data augmentation stuff, I would have always gone for pad because you have the whole picture, right? All data points. Unless you are interested in only some part of the picture, I would say padding would be a nice one because you have the whole picture. But then, for example, the the very first one they had, where they had people in the mall picture, where they had people and trees and cars and buildings. I think if you don't take the whole picture and train on it in some part, you will definitely miss some data out.
Yeah, but over there you could do something like, he talks about this method which picks random crops from the entire image, right? So
So
in a way you're capturing the entire
that's
image.
data augmentation, right?
Yeah.
So like if I didn't know about data augmentation, I would have gone with a crop because I wouldn't lose out. I don't want to lose out the meaning in the whole picture.
Right. Yeah, if you're not aware of augmentation.
I think that answers the next question. What is data augmentation? Basically, data augmentation is, from the same picture, you take different parts of it. So you all have different features of an image that are learned over a period of time, but without changing the meaning. So if you have 50%, like say min equal to 0.5, then you like 50% of the image you take for every transformation. Sometimes it's horizontal, sometimes it's vertical and stuff like that. Sometimes it's the middle part. But like you don't change the meaning of the information, but you always have different features that you can learn upon.
Right.
Whether it is a good one or bad one, I think it's intuitively I thought it is not a good solution, because sometimes you will learn only half of the parts. For example, half of the peers you will see that they have only 1 year or something like that.
Mm-hmm.
But I have done a bit of reading and it seems to be working good. So I think that if it works fine, then yeah. Intuitively, I didn't think that it was a good thing to do a data augmentation, because you are missing out some feature parts. But over a large period, when you train thousands and thousands of stuff, I think that will work out well.
Yeah, I mean, even otherwise, if you're taking, so I particularly like the idea of picking cropping from the same image multiple times so that you have the entire image, making sure that you are capturing at least a certain percentage of the pixels, right? So you are not missing out any information and you have the same size images multiple times. And also it increases the training data that you have. So
Yeah, that it does.
Yeah. So otherwise, for other cases, if you're talking about it misses a part, then you could always use squishing, resizing, and padding. Squishing and stretching and padding.
Yeah.
Again, the training data set would be small. So I think the main reason why you do data augmentation is to increase the data size that you have, more than capturing all the information.
Yeah.
Right.
Yep.
Okay. So what is the difference between item transform and batch transform? We already discussed this one.
Yeah, I think we started with that one.
Yeah.
Item transform, batch transform.
Right.
What's a confusion matrix? Confusion matrix is basically I think we discussed this too. Confusion matrix is basically gives you a relation of how predictor versus actual. It gives a matrix form which is easy to read upon.
Yeah. What does export save? It saves the model as a pickle file.
Mm-hmm. Yep. I think pickle file not as a. I think you can save it as an any file. It doesn't have to be a pickle file.
I think by default it saves a pickle file or something.
Okay. Okay. What is it called? What is it when we use a model for inference? I think it's an inference, right? You basically infer data, so basically that's why we call it something called as inference. When inference, when we use a model for getting predictions,
right?
The same model, when it is used to predict, it's called as inference.
Right.
Right?
Yeah.
Okay.
So what up IPython widgets? So IPython widgets are these UI elements that you could insert in a Python notebook that let you interactively, upload stuff or do make changes and see the result in real time.
Yeah. What is this called when we use a model? When we might use CPU for deployment? I think if it's not very intensive, I think CPU. I mean, generally, if cost is not a problem, I would say GPUs always use GPUs. But like since cost is always a big factor, if there are not multiple data points, multiple incoming data, I think you can use a CPU for doing that same job.
Right. For inferencing, I think mostly you would be using CPU until you are like something like Facebook or Twitter or a massive.
Yeah, like if you have multiple data coming in, for example, image searches.
Yes. Or otherwise, something similar to a generative adversarial network or something that are doing image transformations. So even for single transformation, they use, I don't know how many images and everything to make the transformation.
Basically, it depends upon the processing. So GPUs are hugely popular for parallel stuff. They can do humongously parallel processing. So that is at the end of the day classified. Like if you require your model will actually be predicting on inferring on something which takes humongous amount of data, then yes, GPU is better. Otherwise, for image classification as is, I think CPU can do that.
Right. Yeah, makes sense. What are the downsides of deploying your app to a server instead of to a client device such as a phone or PC? So when you deploy to a server, you'll have to download the data from the client's device, basically fetch the data from client's device and then process it and set it back. If it was deployed at the client's machine, then you don't really have to do that transfer and it's faster. So you could show the result quickly. But again, you're going to consume more resources at the client's end.
Yeah. I think it's always better if we have a server stuff. But today's machines like Google or Siri, they are all inbuilt. Like there is a lot of computation. Even Google Photos that we have, a lot of computation is done inside the machines. I think all of the processors right now have a AI chip as well for that particular stuff.
Data what?
So all of today's processors, SoCs, they have AI chips for this particular thing, that faster GPUs.
Yeah. So you're suggesting that everything happens at the edge device, so the client's
No,
device.
Not everything, but like if it's small stuff, I think one is a good one. And like if it's too power intensive or too hungry, then I mean it definitely makes stuff. Server is the only option.
Right. Yeah, when you're searching on Google with voice or something, I think they transmit the data because if you do not have internet, then it's not able to get the result.
Yeah, but there are some examples like even if you like create an alarm or call somebody or
those can happen.
Those don't need internet and they can work fairly well with the system.
Yeah.
Okay. What are the three problems that occur when rolling out a beer system? I think out of domain data, domain shift, those are the problems that can occur when rolling out a peer warning system.
Yeah, those are the next two questions. What is out of domain data, domain shift? So we've discussed those. What are the 3 steps in deployment process?
The manual, I think we discussed that.
Oh,
the manual stuff.
Last one that you described, yes. And fully automating the everything.
And holding hands and fully automation. Okay. With that, let's take a break, like 5 minutes break, or shall we go to the fun part right now?